Today, my subject is about innovation as to what we are planning to do in the field of electric vehicles and, more importantly, the power behind the electric vehicle. As all of you know, the climate change has triggered fundamentally transformative changes all over the world. The decarbonization that is being required has made two fundamental directional change. I heard Dr. Selvaraj about the impact of changes, which is very, very nicely put. But these two changes also will bring in some impact on societies. One change is on power generation, where everybody is moving away from thermal power generation to renewable power to avoid further carbon emission in the environment. But having said that, in the short term, some amount of thermal power plants still have to come up till the renewable power comes into play. And renewable power, as you know, is not a 24/7 power. It's seasonal. In the case of wind, and in the case of solar, it is during the day. So for renewable power to be effective, you need to have storage solutions. And therefore, there is a huge accompanying demand for storage technologies. Because without storage technologies, you cannot make this transition. So that is one vector of change which is happening not only in our country. Prime Minister has recently in the conference in Glasgow committed that India will reach the net zero goals by 2050 or 70, I don't remember. But consequently, I think India has taken a decision to accelerate renewable power generation. I think we are today around 110, 20 gigawatts. He has set a target of 500 gigawatts by 2030. Now, if that has to really happen, you need to have lots of storage solutions, lots of batteries, because that is today the most efficient form of storage. But there are still other forms of storage I'm sure will evolve. The second directional change is the electrification of mobility. And this is happening rapidly in Europe and is beginning to happen in India. Now, for all this, the heart of the technology today is lithium-ion batteries. And what powers the lithium-ion batteries is the lithium-ion cells. As Dr. Sumantran said this morning, what is chips to integrated circuits is the lithium-ion cells to the batteries. And today it is all dominated by Chinese. More than 80% or 90% of the production capacity of lithium-ion cells are in China. People like CATL and people like Gokshuan and many others are leading the capacity, and they're also setting up capacities in Europe. But Europe is now rapidly catching up in setting up their own capacities. US is a bit delayed, even though a lot of R&D is done in US. The capacity creation is a bit slow because the previous government was not supporting this environmental change. But now with the change of US government, you see an acceleration there. Now, clearly, the demand is so rapid, there's not enough supplies. There's a lot of shortage of materials also. So if India were to go towards this direction, it has to take steps in making ourselves self-reliant. So it is with that concept that TVS Group and Nucleus TVS, we are working on for the last couple of years, more than 3 years, investigating what are the best solutions. When you go into any such new field, it has been our philosophy not to go for what is the current technology, because what is current will soon be overtaken. So we were searching for something which is for the future. Many of you would have heard of solid-state cells, which has been now talked about, and people like QuantumScape have announced they're going to make those cells, but they're not yet in commercial reality. The current state of art of lithium-ion cells technology was pioneered by Sony. Sony pioneered the lithium-ion cells and batteries, mainly for consumer electronics, when they wanted to make the consumer products compact. And from there, the technology spread for laptops and so on. So the process of manufacturing the cell, which is now being adopted globally, is largely process pioneered by Sony, which basically uses a cathode and anode process and a liquid electrolyte, which is filled into the cell as the last stage of the process. The process that we are now planning to implement is what is called as a semi-solid cells. They're not solid state, but they're not entirely this liquid electrolyte. And this process has a lot of innovation in it, where the electrolyte is mixed up front in the formation of the electrode itself. By doing that, it eliminates a lot of subsequent steps. So this technology promises a significant reduction to capital cost in setting up a plant. It also promises less unit cost. And also, because it has got no binders and solvents, it promotes recyclability. So this is a technology pioneered by an MIT startup. We were talking about startups here. I think this is a startup in Boston called 24M, led by a professor at MIT called Yatming Chang, who pioneered this technology. And I came across them about 3 years ago. I went to Boston, I saw it, and then I did 2 years of due diligence, visiting Japan, visiting other parts of the world, to understand the validity of it. Now there are we are one among the 6 global licensees for this technology. Others being Kyocera in Japan, who have set up a plant, and they are making these products and selling in the Japanese market for the storage solutions. There is a company in Thailand called GPSC, which is making this plant. We are the third in India. Then there is a company called Freyr in Norway, setting up a 40 gigawatt hours capacity. And Koch Industries in the US is setting it up in the US. Without taking more time from you, I'm requesting my colleague, Bhavani Shankar, who has prepared a brief presentation on it. I'll ask him to take you through it. At the end of it, I'll be happy to clarify any questions you may have. Thank you.
Yeah, so good afternoon, ladies and gentlemen. I'm Bhavani Shankar, representing Lucas TVS, along with our Chairman and Managing Director, Mr. K Balaji. So just before I go into the presentation, I just thought maybe a quick introduction on our group. So Lucas TVS Group, a 5,000 crore organization, and these are the companies within the group. So we have Lucas TVS, which is a leader in the manufacturing of rotating electrics. They make more than 15 million of these rotating electrics every year, and they supply to all the segments. Then there is Delphi TVS, which again is a leading manufacturer of common rail diesel fuel injection systems, supplying to, again, the four-wheeler, tractor, and also the off-highway as well as the car segments. Then there is Indo-Nippon Electricals Limited, which is a leader in electronic ignition as well as other parts for the two-wheeler industry. Then TVS Indion, which is a new kid in the block in our organization, created for the purpose of manufacturing these semi-solid lithium-ion cells as well as the BMS and the batteries. Then, of course, we have Lucas Indian Service, which has one of the largest network sales and distribution network in India, and they distribute our products as well as that of other companies. And all these companies that I've talked about, all of them have created world-class engineering capabilities in line with our Lucas TVS philosophy to develop the capability within India. So let me talk about the Lucas TVS initiative in developing the next generation technologies, both for the mobility as well as for the energy storage solutions. All of us are aware about the approach of a government for the clean environment. We all are aware about the COP26 commitment, where India proposes to bring in the non-fossil energy to a capacity of nearly 500 gigawatt hour by 2030. Then there is another COP26 commitment where India will fulfill 50% of its energy requirement through renewable power by 2030. Of course, we are aware about NEMMP mission plan of 2020, which aims at bringing in the security, the fuel, nation fuel security through hybrid as well as electric vehicles, and FAME 2, all of us are aware about. So Lucas TVS, in the last 2 years, has actually scanned and investigated several technologies across the world, and then they have actually come up, chosen this innovative next generation, what we believe could be a disruptive technology of the semi-solid technology. And this is pioneered by 24M, a Boston-based company incubated as a MIT startup. This semi-solid technology has lots of advantages versus the conventional technology. I'll talk more about it. And of course, we have a technical license and technical services agreement that provides for complete access for technology going forward in the future. And also we can export anywhere. That means this facilitates us to put up a big, with a global scale plant in India. So let's go into further slides. So 24M technology, I would like to say a few sentences about it. It was in the year 2010 when this company was spun out of MIT. 2014, they got into automated lines were running. And by 2019, this low-cost manufacturing got proven commercially as it was adopted in other parts of the world. And in the last few years, this technology has been expanding rapidly across the globe. And there is a very strong IP fortress. There are more than 103 patents which have been issued and another 147 pending. Some details on the 24M technology benefits, the benefits coming out of this semi-solid platform. I would just like to highlight 3 aspects. Number one is the thick binder-free deformable electrode. Number 2, the single pouch structure that you see there. And number 3, in this process, the electrolyte gets mixed very much in the beginning, unlike the conventional technology where the flooded electrolyte is filled in after the cell has been created. And so what does all this lead to? I think the first thing which really attracted us to this technology was this unprecedented level of safety which this technology brings in this area of cell manufacture. So at the cell level, what you can see here, how it does it is through a unit cell architecture design patented by 24M. And this unit cell architecture design, one, it ensures a prevention of the internal metal contaminations. For instance, the contamination doesn't take place because there is no electrode slitting in this process, and also there is no contamination, metal contamination at the tab welting stage, or for that matter at the can crimping stage. Further, the misalignment which normally causes the short circuit type of failures, that is completely eliminated with this 24M technology process, primarily because the separator is sealed to the outer film. Again, even in the case of the stacked cell format, when we do that, again here the misalignment that can be caused by the short circuit failure, this is also eliminated because the electrodes are insulated by the outer film. And of course, the 100% traceability in this production process. And all this would lead to potential catastrophic failure getting eliminated by design itself.
So maybe this I'll stay for a minute because this is a very topical subject. Today in India, I think everybody is concerned about the safety of the lithium-ion batteries and cells. I think fire issue is not uncommon. As we've seen even in IC engines, you do see vehicles catching fire. Now, what you have is in all these mobility applications, what you have in a battery storage is a concentrated energy, which is there in the form of a battery or in the form of a petrol tank or whatever. And you need only some things to go wrong for that to get ignited. Now, that is the reason that you see many of the incidents that are being reported. There are three things to safety. One is internal to the manufacturing of the cells. If the cells are not manufactured well, then there are potential risks associated with safety. Things like short circuit between the electrodes and so on. What attracted me to this technology was that in this technology, by design, that all those risks associated with at the cell level is eliminated. You still have to take care at the battery level, where the battery management system has to come to play. As you know, when these batteries are used, there is a chemical reaction that's going on inside the battery, and that generates heat and so on. The battery management system is supposed to be the supervisory monitoring mechanism which monitors those functions. And if there is any issue, it is supposed to switch it off or control it or change it. Some of the batteries that are used might compromise for cost reasons on the battery management system. So there are other reasons also. And third, charging. There is this not well understood phenomena. You have seen even in your cell phone batteries, if you charge it very frequently, your life will go down. And the charging generates heat. So there are some protocols for charging that needs to be understood. And finally, the environment. India is a hot country. Our temperatures are high. So another reason we were attracted to this technology is we're designing cells from first principles to suit the climate conditions of India, to make sure that it has the ability to withstand 50 degrees centigrade in the ambient, which is not uncommon to see. Thank you. Carry on.
So what you see here is an LFP 100 ampere hour type of a cell. So undergoing a crush test, and by the end of this crush test, you can see that it's still able to reach UCAR 1, which is a very, very highest level of safety standard. And what you see in the graph is, of course, hardly any change in the temperature is there, even at the end of this test. And similarly for NMC, the latest generation NMC type of a chemistry, lots of abusive tests, lot of data is available, and all this shows it doesn't even cross UCAR 2, which is again a very high level of safety standard. One other aspect I would like to talk on this technology is, of course, the low cost, primarily emanating from a much, much simplified process. What you see on the top is a conventional lithium-ion manufacturing setup. Some of you would have seen it. A long setup with lots of ovens, which is involved for the drying as well as for the solvent recovery and so on. And all these 15 steps have been brought down to just 5 steps. And in the right corner, what you see there is a very compact Gen 2 type of a line where there's a significant reduction on the capex and thereby also lower space, lower utilities, lower labor, and so on. One other aspect I want to touch upon, this technology also allows us to make the cells in a much larger format. So typically, this is very useful when we go in for these applications like grid box or grid block. And for that matter, in mobility, today people talk about the cell-to-pack technology. So this technology would be able to give these advantages.
Just a minute.
Yeah.
Just go back to the previous one. I think some of you may not be familiar with these formats. Traditional batteries you'd have seen, which all of us are familiar with in consumer electronics, cylindrical cells. That's how all the battery cells were pioneered by Sony. And it is the same cylindrical cells which are now being used in the electric vehicles. But the amount of energy you can carry in that small cell is quite limited. In this technology, we can build bigger cells, larger format cells. So when you talk about storage solutions or big buses and so on, the lot of advantages are there because every cell has to be joined. So when you have cylindrical cells, the number of joints that you must have in the battery pack is huge. Whereas in this, it will be considerably less. So this is why we were attracted to go into this technology. We know that when anything new comes, it takes time for people to understand it, accept it. But as I said, there's no point in setting up a plant in 2022 or 23 on yesterday's technology. We have to do something which is contemporary for the future. Thank you.
So the last aspect of this technology I want to touch upon, which is very important. What happens to all these lithium cells after, say, about 10 years? And what happens to these lithium cells which would be coming out of these gigafactories? Some amount of rejections would be there. So that's where the recycling comes in, and that's where the 24M technology offers a very convenient and a very efficient way of recycling, what is shown in this inner circle as direct recycling. Because there is no binder, these raw materials can be separated very easily and efficiently, and also in an environmental friendly fashion, because it does not involve burning of materials like the pyro recycling or dissolving the materials and removing this material like in the hydro recycling. So with all this technology has, as I mentioned earlier, is getting increasingly adopted across the globe. So firstly, this is Kyocera, one of very large Japanese conglomerate which adopted this technology for energy storage, basically for the residential storage systems, commercially produced a system called as Enerza. Then, as we speak, there is another GPSC, which is a part of another large power group called PTT in Thailand. This plant a pilot plant has gone into production just recently last month, and they will also be scaling it up. And what you see on this other corner of this slide is these tuk-tuks, where they have already started using the 24M cell built packs to run these tuk-tuks. Freyr, another company in Europe, which has made big announcements, coming up with 43 gigawatt hour plants in Mo Arena, and they will also go into production in this year, 22. And the other exciting announcement which was there recently in the news was, of course, when Volkswagen endorsed this technology and have entered into a strategic tie-up with 24M. They'll invest into 24M and come up with a setup somewhere near Germany. So this is another, and they will focus a lot on the mobility, of course. And now coming to India, yes, Lucas TVS has a vision to build globally competitive giga-scale plants, addressing both the mobility as well as the storage for Indian market. And as most of us are aware, this demand in India would also come up significantly, and we expect it to cross 160 gigawatt hour by 2030. Our first plant will, of course, be at Thervai Kandigai near Gumudipundi, which, as you see from the map, it's about 55 kilometers from Chennai in the northward direction, and we have a 56-acre site out there. The construction of this the customer qualification plant would start by this Q3 of 2022, and SOP will be by early Q4 of 2023. Yes, gentlemen, this plant will, of course, adopt all the best practices to ensure safety in the environments, safety for the people, safety for the product. It will also adopt the latest Generation 2, Generation 3 type of manufacturing equipments that will be highly automated with Industry 4.0 technologies. We are grateful to the Tamil Nadu government and its agencies like SIPCOT for their unstinted support in assuring us the incentives and also giving us the land and also the promise of uninterrupted power supply, which is very important for this project. Our vision also envisages setting up similar plants in other strategic locations all over India. Finally, I would like to end by mentioning that there is a need for industry, academia, cooperation to develop the materials, processes, and the equipments. We all know that the global demand is really going to go up, so that's going to put a lot of challenge when it comes to raw materials. Our technology is chemistry agnostic, but of course we plan to initially make LFP and NMC chemistries, and also this technology is capable of maybe taking other technologies like sodium ion and so on. And we will be actively working with the chemical industry so that we can develop all these cathode, anode, other raw materials and other materials. And we will be also working very closely with research bodies like IIT Chennai, CSIR, SECRI, and Indian Institute of Minerals and Materials Technology for Recycling, IISc Bangalore, and other such institutes. And we have already started working with equipment manufacturers in India to develop the critical process equipment locally. And in line with our philosophy, we already started investing into the R&D right at the start itself so that we can develop the products to suit Indian operating conditions and also to achieve that ultimate goal of Atmanirbhar. Thank you.
In a way, I think in TVS Group, just like in the 60s when we started to start the parts manufacture, there was nothing available in the country. Everything had to be imported. I think we are something in a similar state in this technology area, which is a new field on electric mobility. There's no equipment being made in this country. There's no raw materials available in this country. Everything has to be built from scratch. So somebody asked me as to why are you getting into such a difficult area? I said that's really the purpose of any venturing. So in a way, for us, it's a bit of an adventure to get into this field. We know there's going to be a lot of challenges, a lot of difficulties, but we are convinced that this is the right direction. And hopefully, when we meet a few years later, when the product is already in the market and so on, I'll have more things to share about our vision. But I think anybody setting up business or factories in India today should not set up factories only for the Indian market. We should always set up factories for the global market. You must think that you're going to be competing all the time with the best in the world. And that's what we have to hope to do. And our aim is not only to supply to customers in India, our aim from the beginning is to address this technology to address the global market. Thank you.
Thank you very much, both Mr. Bhavani Shankar and Mr. Balaji. So I have just one question to ask of you, a very lay perspective question. He made a reference to the usage of IoT, to the usage of 4.0. What is the kind of employment that this will generate?
Well, I think this is not employment intensive.
Yeah.
So in our cell plant, I think when you go for 5 gigawatt hour, the total strength may be about 1,500 or something like that.
1,500.